Ever wondered how blockchain technology works? Well, you're not alone. Blockchain technology, in its simplest form, is a type of database. But it's not just any database. It's a unique one that stores information in blocks that are then chained together. Picture a digital ledger of transactions, like a diary that you keep on your computer. But instead of being stored in one place, it's distributed across many computers around the world. Each new piece of information, or block, is added to a chain of existing blocks. But here's where it gets revolutionary. This technology allows digital information to be distributed, but not copied or changed. That's right. Once a block is added to the chain, it's there for good, unaltered and unalterable. So, at its core, a blockchain is a chain of digital information, stored in a public database. Now, let's delve deeper into this intriguing world of blocks and chains. Now let's break down what these blocks in a blockchain are. Picture a giant tower of digital Lego. Each of these Lego bricks can be considered a block, and just like how every Lego brick is unique, so is each block in a blockchain. Blocks are the mainstay of blockchain technology. But what gives each block its unique identity? Well, it's all down to the data it carries. Each block contains a bundle of data. This could be transaction details, such as the date, time, and amount of the latest Bitcoin you bought, or it can be the information about the latest contract you signed on a blockchain platform. Now here's where it gets interesting. Every block in a blockchain has a unique code, known as a hash. This hash is like the fingerprint of the block, making it distinct from all other blocks. The hash is created by a function that transforms the data inside the block into a string of characters. No matter how much data is in the block, the hash function always produces a string of the same length. But the magic doesn't stop there. Each block also carries the hash of the previous block in the chain. This creates a link between the blocks, forming what we call a chain of blocks, or simply, a blockchain. If anyone tries to tamper with the data in a block, the hash of the block changes. And because each block carries the hash of the previous block, a change in one hash will disrupt the entire chain. This is what makes blockchain a secure and tamper-proof technology. So, in essence, a block is like a page in a ledger or a record book. Each page records transactions and carries a unique stamp. The pages are linked together through these unique stamps, creating a chain of records. That's why we often refer to blockchain as a digital ledger. So each block is like a digital ledger of transactions linked to the previous block through a unique code. And that, my friends, is the beauty of the blocks in a blockchain. You might be wondering what makes blockchain so secure. Well, the security of blockchain, in essence, revolves around two key principles: its unique structure and the use of cryptographic hashes. Think of the blockchain as a line of dominoes. Each block is like a domino, and they all link together to form a chain. Now, if you were to change the information in one block, this would be like removing a domino from the line. The links that hold the chain together would break, causing a domino effect that disrupts the entire chain. This is because each block in the chain contains a unique code, known as a cryptographic hash, which is intrinsically linked to the contents of the block. Now let's delve a bit deeper into these cryptographic hashes. Each block's hash is created by a mathematical function that transforms the information in the block into a string of numbers and letters. This string is unique to the contents of the block. Change even a single character in the block, and the hash will change completely. But that's not all. Each block also contains the hash of the previous block in the chain. This creates a sort of digital wax seal, confirming the authenticity of the previous block and linking it to the next. So if someone attempts to alter the information in a block, the hash of that block will change, which in turn would change the hash contained in the next block, and so on. This would break the chain, making the alteration evident. The beauty of this system is that it is self-regulating. The network checks and verifies each block against the one before it. If the hashes don't match up, the network knows something's awry, and the block is rejected. In essence, the security of the blockchain is built into its very DNA. The structure and use of hashes make it extremely difficult, if not impossible, to alter information once it's been added to the chain. This fundamental characteristic of blockchain technology makes it tamper-proof and secure. Another important aspect of blockchain is its decentralization and transparency. Let's dive deeper into this. Imagine a world where there's no central authority, no one supreme entity controlling everything. Instead, power is spread out evenly across a network of participants, each having equal say and responsibility. This is the essence of decentralization, and it's one of the key features that make blockchain technology so revolutionary. In a blockchain, there's no central storage point. Rather, the information, or blocks, are distributed across a network of computers known as nodes. Each node holds a copy of the entire blockchain, continuously updated with every new block added. This ensures that even if one node goes down, the blockchain remains intact, as the other nodes retain the full record. This distribution of data makes the system highly resilient and robust against failures and attacks. Now, let's talk about transparency. In a traditional system, transactions are often shrouded in secrecy. On the contrary, in a blockchain, every single transaction made is visible to everyone on the network. But wait, doesn't that compromise privacy? Well, not exactly. While the transaction details are public, the identities of the parties involved are kept anonymous, represented only by their unique digital signatures. This ensures both transparency and privacy. Moreover, once a transaction is added to the blockchain, it is practically immutable. This means it cannot be altered or deleted, providing a permanent, indisputable record. This feature enhances trust among participants as they can verify transactions independently without relying on a third party. Transparency and decentralization together create a unique environment where trust is built not on individuals or institutions, but on the system itself. It's a system where power is not concentrated but dispersed, where operations are not hidden but open for all to see. This decentralization and transparency make blockchain a trusted and democratic system. With blockchain, we are moving towards a future where trust is digitized, transactions are transparent, and power is in the hands of the many, not the few. So, where is blockchain technology being used in the real world? Well, the most well-known application of blockchain is in the world of cryptocurrencies. Yes, you've probably heard of Bitcoin, the first and most prominent example. But there are many others too, like Ethereum, Ripple, and Litecoin. These digital currencies use blockchain technology to record transactions and create new units. The decentralized nature of the blockchain ensures that no single entity has control over the entire network, making it resistant to fraud and manipulation. But the potential of blockchain extends beyond digital currencies. One compelling application is in the realm of smart contracts. These are self-executing contracts with the terms of the agreement directly written into the code. They automatically perform transactions and other actions when certain conditions are met. This eliminates the need for a third party, making transactions faster, cheaper, and more transparent. Another exciting application of blockchain is in supply chain management. By using blockchain technology, companies can create a transparent and tamper-proof record of product movement from production to delivery. This can help reduce losses from fraud and improve efficiency. For instance, in the food industry, a blockchain-based supply chain could help quickly identify and isolate contaminated products, potentially saving lives. Blockchain is also being used to create decentralized digital identities. This could provide a secure and private way for people to verify their identity online, protecting them from identity theft and fraud. In the healthcare sector, blockchain could enable secure and private storage and transfer of medical records, making it easier for patients to control their own health data. In the energy sector, blockchain could facilitate peer-to-peer energy trading, allowing consumers to sell excess energy directly to their neighbors, bypassing traditional utility companies. In the world of art and music, blockchain could enable artists to sell their work directly to fans, bypassing traditional intermediaries like galleries and record labels. These are just a few examples of how blockchain is revolutionizing various industries. So there you have it, a simple explanation of how blockchain technology works. We've journeyed through the intriguing world of blockchain, understanding it as a chain of blocks, each containing unique data. We've explored how this revolutionary technology assures security through complex cryptographic principles, making it nearly impossible for data tampering. We've also delved into the concepts of decentralization and transparency, two fundamental attributes that make blockchain a game-changer. Decentralization eliminates the need for intermediaries, while transparency fosters trust and accountability. We've seen how these attributes translate into real-world applications, beyond just cryptocurrencies. From supply chain management to healthcare, from voting systems to intellectual property rights, the possibilities seem endless. Blockchain technology is indeed transforming the way we perceive and interact with digital information. Next time you hear about blockchain, you will know exactly what they're talking about. Until then, keep exploring, keep learning,